cantilever, truss, tied arch, suspension, and cable-stayed types of bridges. But it seems we need to add a new type of bridge, the mingle-mangle bridge. The protagonist of the builder of this mingle-mangle bridge is the legionary ants. Unlike most ant species, legionary ants do not construct permanent nests. A colony of legionary ants moves almost steadily over the time it exists. They move to look forward to a new foraging area. However, rivers, valleys, or bumps are lying in the marching road of the legionary ant colony. They should pass through the geohazards unless they don't take a detour. It's the time that the master builders of the bridge show their ability. The colony builds a bridge to pass through the hazards. The primary construction material of this bridge is ants themselves. But don't worry. This bridge is not permanent. Scientists have studied the mechanism of this bridge building. It will help to develop a new control algorithm for the swarms of robots and drones. Researchers have found that legionary ants use simple rules to build a bridge. The front of a colony that meets a hazard slows down its speed, but others are kept moving at the same speed. Then the backup party walks on the ants' back of the advance party. This simple rule is repeated over and over until an ant passes through the hazard and maintains a normal walking speed. So no director is managing the construction. Interestingly, the scientists also found that the legionary ant colony doesn't calculate the shortest path to cross a hazard. Usually, a colony spares 20% of members to construct a bridge and saves the rest to work for foraging. Researchers say that this characteristic of the legionary ant's swarm intelligence results from the cost-benefit trade-off. This wisdom of the legionary ants inspires mathematicians and computer scientists to solve complex problems of humans.